Hey everyone, welcome to this explainer from the Technic Planner. I am absolutely thrilled you're tuning in today because we are diving deep into the real-world physics of project schedules. If you've ever stared at a Gantt chart and wondered why the dates just don't seem to reflect what's actually happening on the ground, well, you are in exactly the right place. We're going to demystify some of the most misunderstood concepts in the entire field of project controls.
Look, we have to acknowledge a universal industry problem right out of the gate. Planners everywhere use the word lag for absolutely everything. A delay? That's a lag. An overlap? That's a lag too. In day-to-day conversation, that might seem harmless enough, but in proper schedule logic, forensic review, and governance, it is creating massive confusion. Lead and lag are not the same thing, and mixing them up can completely compromise your schedule's integrity.
Okay, let's dive into this. Here is our project baseline for today. We'll start with the great scheduling confusion, define how lag equals a gap and lead equals an overlap, expose the software trap, discuss governance and better alternatives, and lock in our final takeaways. All right, part one, the great scheduling confusion. To build a defensible schedule, we really have to strip away all the software jargon and focus on physical behavior. If you take away just one thing today, let it be this mnemonic anchor. Lag pushes activities apart, but lead pulls activities together. It's truly that simple. A lag creates a gap or a waiting period, effectively delaying the successor. A lead creates an overlap, allowing for fast tracking, advancing the successor, so the two activities actually happen at the same time.
Moving into part two, lag equals gap. Let's formally define what this means in the physical world. A lag is the amount of time by which a successor activity is delayed in relation to the predecessor activity. And this brilliantly illustrates exactly what we mean when we talk about a waiting period. It represents a physical reality where something literally cannot happen yet.
Let's translate that software syntax into plain English. Say you have concrete pour, finish to start, plus 7 days. That is a lag. It means you pour the concrete, and then you must wait exactly 7 days for that concrete to cure before you can begin installing equipment on top of it. With a true lag, something is always physically waiting. Paint drying, grout setting, a statutory permit response period. These are real, justifiable gaps that push the next activity out. Which brings us to part three, lead equals overlap. Now, this is the exact opposite concept, and it's heavily used to compress schedules. A lead is formally defined as the amount of time by which a successor activity can be advanced in relation to the predecessor activity. Instead of pushing the next task away, a lead pulls the activities together, allowing the successor to start before the predecessor is fully complete. Let's look at another real-world translation. Install cable, finish to start minus 2 days. This means that while the cable installation is still going on, you're going to start testing the cable 2 days before the installation is completely finished. You can probably picture it right now on the job site, right? Two overlapping tasks happening simultaneously. You're fast tracking. Work is overlapping. That is a lead. Okay, part four, the software trap. Now, what's really interesting about this slide is if the concepts are this clear on a job site, why is everyone so confused? Well, it's because planners often get lost in the deep, dark tunnels of software complexity. Both Oracle Primavera P6 and Microsoft Project set a massive trap for us. They put lead and lag values into a single data field that is almost always just labeled lag. So even when you're entering a lead, the software calls it a lag. This is the root cause of the industry's language problem. So we have to look past the field name and just break down the math. Every schedule relationship actually equals a logic type, like finish to start or start to start, plus a timing modifier. A positive value is a lag, which delays the successor. A negative value is technically a lead, which advances the successor. So when P6 or MS Project asks you to enter a negative lag to create an overlap, they are technically asking you to enter a lead. It's an absolutely crucial distinction to make in your mind, regardless of what the software box is called. Next up, part five, governance and better alternatives. These seemingly harmless software quirks can actually get your project baseline rejected. The Defense Contract Management Agency, or DCMA, has strict assessment guidance for schedule quality. DCMA check number 2 explicitly requires 0 negative lag relationships in the schedule. 0. Why? Because negative lags severely distort your total float. They obscure the true critical path, and they create totally unrealistic scheduling behavior the moment durations begin to change. So, the crucial point is this: we need better ways to model overlap.
Instead of using a finish-to-start relationship with a 10-day negative lag between engineering and procurement, technic planning best practice suggests a much more transparent alternative. Consider a start-to-start relationship with a positive 20-day lag. This tells a much truer story. Procurement doesn't randomly start 10 days before engineering finishes. Rather, procurement starts 20 days after engineering begins, once enough design progress has been made to actually allow purchasing to kick off. Before you enter any offset in your software, walk through this practical checklist. First, is something physically waiting? If yes, a positive lag might be okay. Second, is work overlapping? If yes, you're dealing with a lead, and you should really try to avoid negative lag. Third, is that lag hiding a missing activity? Instead of a 14-day lag for approvals, just create a 14-day approval review activity. Fourth, are you just using negative lag to force a date? And finally, is the relationship stable if durations change? Use intermediate milestones, split your activities into phases, and please stop hiding work inside invisible software lags. Finally, Part 6, Final Takeaways.
Let's move to and see how this builds a much stronger foundation for your projects. Professional scheduling isn't just about punching numbers into a spreadsheet so the dates calculate the way your boss wants. It's about modeling real-world sequences transparently, auditably, and defensibly.
So I want to repeat our mnemonic anchor one final time to ensure total retention. Say it with me. Lag pushes activities apart. Lead pulls activities together. If the successor is waiting, it's a lag. If the successor is overlapping, it's a lead. Master this, and you'll immediately elevate the quality of your planning. Which leaves us with one final, provocative question to ask yourself as you look at your own projects today. Are your schedules modeling reality, or are you just forcing dates with invisible lags? If you found this explainer helpful and you want to continue mastering the art and science of project controls, please hit that like button, subscribe to the channel, and drop a comment below letting us know how you handle overlaps in your schedules. Thanks so much for watching and keep planning for success.